Hello everyone, you are all welcome to lecture number 954, and today's topic is the sulfur and non-sulfur vulcanization of rubber part 2. In part 1 I have already discussed, and now I am going to discuss how the ratio is maintained between accelerator and sulfur, and with that ratio how we can get vulcanite, or we can say ebonite, or another term hard rubber, by cross-link of the sulfur with isoprene unit with the help of free radical mechanism reaction. And in this process different types of amino and aldehyde derivatives are used, like thiazole and some other amino derivatives, and they are responsible of improving the quality of rubber and hardness, strength and resistance to abrasion. And also these hard rubber which are produced, that is vulcanite, is having very good property of insulator. It can act as very good insulator, and also it is having all the properties of good quality resistance, and it can be molded, it can be made into different shapes. So all these properties are there. So here number one, sulfur vulcanization. So first now I am discussing the sulfur vulcanization. In this process the rubber is heated with sulfur or carbon sulphide, that is CS2, in presence of accelerator, and such as aldehyde thiocarbamates and thiuram sulphides, and then gonadines, thiazoles, thiocarbonylate and thiocarbazole. So these are all very good accelerator, and they play a very important role. And the percentage and ratio of accelerator with sulfur, that is going to play a very important role in sulfur vulcanization. This accelerator alone or in combination make it possible to vulcanize rubber within any desired time and at any temperature. So the time and temperature, whatever is desired at any desired temperature and time, and these accelerators and sulfur, they are going to maintain. Number two, by the proper choice of accelerator and the sulfur accelerator ratio, it is possible to control any important properties of rubber. So the important properties of rubber can be controlled by maintaining the ratio of these amino derivatives, thiazole and that is guanidine, thiocarbazole with sulfur. If it is in control ratio, the properties of the rubber can be maintained, especially the physical and chemical properties. Number three, the process of curing involves the formation of various types of cross linkage, such as sulphide cross linkage, disulphide cross linkage, formation of sulfur heterocycles, and formation of carbon-carbon cross links through the intervention of free radical intermediates or sulfur catalyzed dehydrogenation at selective site. Number four, ebonite or hard rubber or vulcanite. So these three are having same meaning, either ebonite, vulcanite or hard rubber. Contains about 32% sulfur The cross-linking of the isoprene unit is attained to such an extent that vulcanite has practically no elasticity. So cross-linking of this sulfur with isoprene unit is made in such a way that the rubber will lose its elasticity and it will become hard rubber. Elasticity, hence, ebonite or vulcanite is tough, high resistance to abrasion, and can be molded, sewn, drilled, and even polished. Vulcanite, ebonite has been found to have excellent insulating properties. So number 5, it should be noted that optimum cure of rubber is obtained by incorporating requisite quantity of sulfur per 100 gram of rubber. If quantity of sulfur is more than required, then the product is said to be over cured, with consequent loss of extensibility. For the vulcanization of natural rubber, a typical vulcanization mixture consists of, so once we are going to vulcanize a natural rubber, we are preparing a typical mixture, a ratio of all these substances. They are given here. The rubber, natural rubber will be 100 part, sulfur will be from 0.23 to 1.5 parts, accelerator, that is ZNO, will be from 1 to 10 parts. Then soap, that is zinc chloride, will be from 1 to 5 parts, and antioxidant will be 1.5 parts. So these are all the ratios of that mixture of vulcanization of natural rubber is maintained. But of course this ratio, it is given here, it varies from 1 part to 10 part, varies from 1 part to 5 parts, and as it is desired by the producer that what quality of rubber they want, is it for rubber band or for tire or for tube or for some other purposes. Number 6, the vulcanization of heavy duty rubber can be carried out by mixing reinforcing fillers such as carbon black. So carbon black plays very important role. It is used as reinforcing filler in manufacturing of tire, rubber, ribbon, globe, which is made up of rubber, and in tire especially the carbon black may go up to 50 part and 10 part rubber and other accelerator. So carbon black, the degree of reinforcement depends upon the amount of filler, nature of rubber, particle size of carbon, and its structure. The tensile strength, stiffness, abrasion resistance, etc. of vulcanized rubber are also improved by adding reinforcing fillers. The common filler is carbon black, which forms the chemical bond with the rubber hydrocarbon during the processing. Due to these chemical bondings, the final product becomes stiff, abrasion and tear resistant. The vulcanized rubber is relatively soft. These rubbers, vulcanized ones, are useful for rubber bands and globes. A typical rubber tire used in manufacture of tires contain 50 parts by weight of carbon black. So with this I will stop, and in the next lecture I am going to discuss the vulcanization of rubber, and that is non-sulfur vulcanization, that is in presence of titanium, selenium, zinc oxide, some other ingredients apart from sulfur. Once again, thank you very much for watching the lecture.